One, two, three. Start. Good afternoon, everyone. This is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Please, before we go into today's topic, do not forget to like, share, subscribe, and click on the notification button so that you can have more of my video. Today, we are taking a topic under electromagnetic induction part 2. I have done the part 1. In part 1, I proved the formula that can be used to evaluate the value of the electromotive force that can be produced from a typical generator. I also bring to our notice too the concept of Faraday law of electromagnetic induction. The law let us realize that we can generate electricity through the motion of a conductor in an electric field, or through the changing electric field in which a conductor is placed that current can be generated. So today we want to solve a problem as regards a generator. Thank you. Now this is the question. The question says a 60 Hz AC generator having a coil of surface area 5 times 10 raised by minus 3 meters squared and consists of 1500 loops. The magnetic field inside the generator is 0.1 Tesla. The first question says determine the angular speed of the coil of the generator. The second question says evaluate the output peak voltage of the generator. The next question says calculate the root mean square value of the output voltage generated. Then the last question says if 50 ohms resistor is connected across generator, what will be the root mean square value of the current that will flow? Now, before we solve this problem, I want us to take note of something. In AC circuits, there are 3 categories of measurements of either current or voltage. Now, if we take a value of the voltage up to this level, that value that we measure down is called the peak value. Peak value. That's the measurement. Now, another thing I want us to also take note of is that there are 2 averages that we want to take, which is called the root mean square value. Root mean square value. And the last one is the average value. V average. So, concerning what I have put on the board, the peak value of the voltage, that's the maximum value that the voltage of an AC system can attain, is said to be greater than the root mean square value of that voltage, and the root mean square value of the voltage is said to be greater than the average value of the voltage. Please take note of that. The same thing is applicable to current too. Greater than RMS. This I stand for current, then greater than AV. So IAV. Now, the relationship between peak value and RMS is this. Peak value of voltage is square root of 2 times RMS of voltage. Also, peak value of current is square root of 2 times IRMS of current. What do we mean by RMS? RMS is an average measurement that enables us to compare the value of either current or voltage in an AC circuit with that of a direct current. So don't let us go into that details for now. Now, just take note of that. Then, like I said the other time, we can generate electricity. Let's say this is the pole of a bar magnet. This is the north pole, and this pole is producing magnetic field. These are the magnetic lines of force that are coming from the north pole going towards this south pole. This is the south pole of the magnet. So the magnetic field, this space around which the magnetic force can be experienced, that space is called the magnetic field that is being produced by this magnet. Now, according to Faraday, he made us realize that if we place a loop of conductor, like a coil of wire here, and we rotate this coil of wire, he made us realize that electric current I will be produced. Either that we rotate this coil of wire, or we change the magnetic field that is crossing this coil of wire. If we change this, electric current will be produced. So we are made to realize that situation like that can happen. Now, this is what is the simplified form of the content of a typical electric generator. So that means this particular this electric current that is generated will bring about an output that look like this into our household. So we can connect this to electrical system. Let's say I have a resistor R here, and in the question, this particular question, this is 50 ohms resistor. So this particular output that we generate, I'm talking about the voltage that we generate from this generator, is what I enlarge here. So it's being fed into a circuit that contains 50 ohms resistor. So we are coming to this question number D now later. I'm trying to illustrate what is happening. And the surface area of this coil is given as A. And we should also remember that electric flux, that's the amount of electric line of force that is passing through this surface area of this coil, is represented with this symbol, and the unit is Weber. The unit of magnetic field is Tesla T. We normally use capital letter T for the unit of magnetic field. So now the relationship between this magnetic field and this magnetic flux. Magnetic flux is simply the number of magnetic lines of force that is passing through this unit area. So electric field B is related to this magnetic flux by magnetic flux through the surface area of this coil all over A. Just take note of this also. Now, in my last video, I've already proved the formula we can use to evaluate the electromotive force or the voltage that is being generated from electrical generator. And in that particular video, it has been established using Faraday's law of electromagnetic induction that this E is same thing as this magnetic field, this space around this conductor, times the surface area, then times number of coil. This particular conductor can be wound in several ways. So the number of wounds of this coil, this particular coil, is represented with letter N. And the rotation of this coil is called the angular speed. So angular speed. Then sine omega t. T is talking about time, because the value of this E changes with time. Now, at a point when omega t become 90 degrees, which is equivalent to pi all over 2 radian. At that particular moment, sine omega t become 1. So the peak voltage of the generator can be written as this magnetic field B times surface area of this coil, then times the number of turns of that coil. How many times we wound the coil? So times number of coil, then times the angular velocity or angular speed. Also take note of this. Angular speed is defined as angular displacement divided by time. So this angular speed can also be written as omega t is equal to theta. So angular displacement can be written as theta, which is angular speed times time. Take note of that. Now let's go to this question. The questions supply us with the frequency. The frequency is the number of revolution, how many times this coil rotates per unit time. That is frequency, and it's measured in Hz. So frequency F is equal to 60 Hz. Then we are given this parameter to the area, the surface area of this coil. The surface area A, we are given as 5 times 10 raised per minus 3 meter square. So we are given A to be 5 times 10 raised to power minus 3 meter square. Then another thing we are given is the number of loops. This loops is number of turns. That is N, which is 1,500 loops, or we also call it turns, number of turns, N. Now the magnetic field inside generator is 0.1 Tesla. It's talking about the amount of, the magnetic field, the field amount of the force that can be, magnetic force that can be experienced within this space, which is magnetic field B. In this question, the magnetic field B is given as 0.1 Tesla. This T stands for Tesla. So magnetic field B is given as 0.1 Tesla. Now, the first question says, determine the angular speed of the coil of the generator. Like I said the other time, angular speed can be written as angular displacement divided by time. And for a full revolution, this angular displacement total will be 2 pi. And the time taken for one revolution is called period. And 1 over period is given as a frequency. So this thing can be written as 2 pi frequency. That means 1 over t is frequency. So angular speed now, question A, angular speed now is 2 pi frequency. So we are going to multiply 2 times pi, then times the frequency, that is times 60. So if we use our calculator, let me check this value. Okay, in the calculator we are having 377, and then the unit of angular speed is radian per second. Radian per second. So that means the angle of rotation is 377 in 1 second, and that rotation is measured in radian. Then the second question says, evaluate the output peak voltage of the generator. The output voltage of generator is what I put here, which is given as the magnetic field times surface area of the coil times number of turns of the coil, then times angular speed. And the angular speed here that we have here is what I've already obtained there. So the peak voltage now will be this magnetic field, and the magnetic field is 0.1. So I put it there. Then times surface area. The surface area is this. I put it there. Times 10 raised power minus 3. Then times number of turns. The number of turns is 1,500 loops. So times 1,500. Then times angular speed or angular velocity, which is 377. That's times 377. So using our calculator and press this parameter, the answer we are going to have is 282.75 volts. So that means the peak voltage of this generator is 287.75 volts. So that's for that. Now, the next question says, calculate the root mean square value of the output voltage generated. You know, the peak voltage EP can be written as Vp. And relationship between this peak value of the voltage and the root mean square value is a square root of 2 times root mean square value of the voltage. So making root mean square value the subject of the formula, we divide both sides by root 2. So I have V peak divided by root 2 is equal to root mean square value of the voltage. So I'm bringing this one now. This is solution C. I'm bringing this one here now. The value of our peak value that we got, which is this, I can write it as Vp, is that's 287.75 divided by root 2 will give us the root mean square value of the voltage of that of the particular generator. And pressing our calculator, I'm getting 199.9 volts. So this is the root mean square value. If you look at the answer I got for this root mean square value and the answer that I got for the peak value, you can see that the peak value is greater than the root mean square value, which confirm what I wrote here. I said the peak value of the voltage must be greater than the root mean square value, and the root mean square value must be greater than the average value of the voltage. So the next question says that if 50 ohms resistor is connected across the generator, what will be the root mean square value of the current that will flow? So now, according to Ohm's law, we know that voltage is equal to current times resistor, but in AC circuits, we normally make use of the root mean square value of the voltage. So this voltage now become V root mean square value is equal to I root mean square value then times the resistor in the AC circuit. The root mean square value that we got is 199.9, so I will substitute it. 199.9 is equal to I RMS that we are looking for, then times R. That R is what we are asked to find, the value of the resistor, which is 50 ohms. So we put 50 here. So we divide both sides by 50 to get our high RMS. So I'm bringing this calculation up here. So making I RMS solve the formula, I'm having 199.9 divided by 50. So from the calculator, the RMS is approximately equal to 4 ampere. The root mean square value of the current is approximately equal to 4 ampere. That means 4 ampere current will be generated when we pass through the 50 ohms resistor when it is connected to the AC circuit. Thank you so much. I believe that you must have, learned one or two things concerning a problem under electromagnetic induction. Please do not only listen to this tutorial. Also, try as much as possible to think on how you can also improve on the knowledge concerning this particular topic in physics. I believe you can do it. I believe you are able. Please do not forget to share, like, subscribe. Also, click on notification button to have more of my video. I will be looking forward to having your comments. Thank you so much. Have a nice day. Bye.